All right, this is Honors Algebra 2 Pre-Calculus. We're doing section 8.8 in Algebra 2. This is our third video in the sequence and the final video of Chapter 8. So we're solving radical inequalities. When we're solving inequalities, we solve them the same way that we solve equations with the two caveats. We need to flip the inequality sign in two situations. Caveat number one, if we multiply or divide by a negative number, and number two, in the minus case of a plus or minus when we take a square root, which won't happen a bunch here because these problems already have square roots. So let's go ahead and work on solving this. So there are actually two issues at play here. One of them is that I have to solve, okay, and I'm going to solve using SADMAP. But the other issue at play here is that we have a domain restriction, right? So there's two issues at play here. So when we solve, right, I'm going to go ahead and solve using SADMAP. There is no subtraction or addition here. There's no division or multiplication, but I can go ahead and deal with that exponent. So I'm going to square both sides of my inequality, and I'm going to get an x plus 1 is less than a 4. When I solve, I get x is less than 3. So that's the first half, right? But there's another thing at play here, which is that we have to be careful about what we put inside of an even root, right? So we know that the radicand, right, which is the thing inside the root, has to be greater than or equal to 0. So that means x plus 1 is greater than or equal to 0. X is greater than or equal to negative 1. So put together, these two solutions, if we put these on a number line, and you don't have to do the number line step, but if it's something you personally need, that's great. If you don't need it, that's also fine. These look like this, and the word and means overlap. So my answer is going to be this window in the middle. So the answer I'm expecting is bracket at negative 1 up to 3 with a parenthesis, right? There's a couple different ways to check this. One way is to plug in numbers and see if those numbers actually work, right? To see if you could plug in numbers that are smaller than negative 1, which you certainly can't. If you tried a negative 2, you'd get imaginary numbers. And you can try plugging in numbers larger than 3 to see what would happen, right? An easy one to check is 8, because 8 plus 1 gives you the square root of 9, which is too big. So it's very likely that these are my correct answers, but the easiest way to check this is to actually go to the calculator. And remember, when we check, what I would recommend that you do is put into your y1 the left-hand side minus the right-hand side. And since you're looking for when this thing is less than 0, right, it would be below the x-axis. So what we're looking for in our calculator when we check, we're going to type in the square root of x plus 1, close the parentheses, minus a 2, right? And we're going to graph, and we're going to look with our eyes to see where this thing is physically below the x-axis. And sure enough, that's my window, right? And you can second calc 0 if it helps, but it's pretty clear that it's the 3 we were expecting. So if we go over here, we're to the left of the 0, we cross the axis, hit enter, and sure enough, there we are. So if you were checking this on a calculator, again, the easy way to check on a calculator is to make one side of the inequality 0, and then you're just comparing things to where it stands relative to the x-axis. And sure enough, that's my answer from negative 1 with a bracket to 3. All right. Let's go ahead and solve another one, right? Again, there are two issues at play here, right? So the first issue at play is that you actually physically have to solve, right? And the second issue is that this even root has a domain restriction, right? So two issues, right? So first issue, when we go to solve, right, I'm going to use SADMAP. In this situation, there is no subtraction or addition, there's no division or multiplication, but we can get right to the exponent, right? So I'm going to square both sides and get that 2x minus 3 is less than 25. So 2x is less than 28. And then I'm going to divide by 2 to get that x is less than a 14. So that's the first half, right? But the second half of stuff that I have to worry about is my domain restriction, right? So the radicand, which is to say the inside of the root, right? Radicand has to be greater than or equal to 0. So 2x has to be greater than or equal to 3. X has to be greater than or equal to 3 halves. So now I have both of these things in conjunction together, right? So remember that and means overlap. So if we look at this on a number line, here's 3 halves, right? Here's 14. And so we're looking for the window between them, right? So the window I want is right here, and the answer I'm expecting is bracket 3 halves, comma 14 with a parenthesis, right? So that's what I'm expecting. Now you can check this in a couple different ways. You could plug in some numbers and see what happens. Like you could see if numbers outside of this interval would work. An easy one to check that's smaller than 3/2 is 0. If you plug a 0 in here, you obviously get a negative inside your root, which would be imaginary. An easy number to check on the other side of 14 might be, let's say, 15, right? So then you'd get 30 minus 3, right, which is a 27. The square root of 27 is bigger than the square root of 25, which is what 5 would be. So sure enough, numbers on either side of that don't work. The other way to check it, and we saw this in the last one, is to subtract the 5 over, right? So my y1 is going to look like this, minus a 5. And then we're looking for when this thing is below the x-axis. And I can see that this is not the new graph, right? This is still the last graph from example 5. But I could go ahead and type in 2x minus 3. And then subtract the 5, and we can look and see. And sure enough, now we can't see all the way up to 14, so we'd have to change our window a little bit and change our x scale. Let's say we go to 20, but it's going to be exactly what we suspect, right? This window right here from essentially 1.5 included up until a 14 with an open circle would be the window that I'm looking for, all right? So let's go ahead and keep going. So let's look at E6. So in E6, we're going to solve. Now remember, there are two things at play here, right? So one of them is that I have to solve, and the other one, right, is that I have to worry about the domain restriction. And I mostly just gave myself a little bit more space here because it's a little bit more complicated of a problem. So I'm going to bust out the domain restriction. So the trick is that even without the domain restriction, if I solve first, I can actually tell you that there's a trick to this problem, right? So let's go ahead and solve first. And we'll see in a second. We'll do it without the trick. I know some of you are going to spot the trick while I do it, and that's totally fine. But we'll walk through the trick after. So I'm going to solve by SADMEP, which means I'll do subtraction and addition first, right? So I'm going to subtract that 13 over and get is greater than 3, right? So at this moment, there's something that I can spot, and we'll talk about it in a second. But let's say I don't spot it, right? So I did my subtraction and addition, right? The next step I'm going to do is division and multiplication. But remember that when I divide by a negative, I have to flip the direction of the inequality sign. So I'm going to get root 2x minus 6 is less than negative 1, right? Then I'm going to go ahead and deal with my exponent, right? I'm going to square both sides. And again, somewhere in this spot, some of you might be spotting a trick, and that's totally awesome if you are. And if you're not, that's also okay. So I get 2x minus 6 is less than 1, right? So 2x is less than 7, and I get x is less than 7/2, right? And we'll talk about why there's sort of a trick to this after. Now for the domain, I'm looking for x minus 6 to be greater than or equal to 0. So, sorry, 2x minus 6 rather. So 2x is greater than or equal to 6, x is greater than or equal to 3. Now, if you put these two things together, right, if you put them together, you might say to yourself, oh, that's cool. So here's 3 and here's 3.5, which is what 7/2 is, right? This window goes up, this window goes down. Oh, I must be looking for this window in between, right? So your brain might say that's the right answer, but that's actually not the right answer, and this is why we're going to check. Now, I didn't write check here, but you should always check when you're solving anything involving even roots. So there's a sort of a logical fallacy here, and we're going to see that if we put this in our calculator, right? So if I put in my y1 in my calculator to check this and see what answer I get, I'd subtract the 16 over, right? So this would be minus 3, and I want above the x-axis, right? So I want this to be above the x-axis, right? That's what I'm looking for. If this is my y1, I'm looking for what's above the x-axis. So I'm going to have a negative 3 square root of 2x minus 6 all minus a 3, and I'm looking for where this is above the x-axis. Well, you'll spot that it's never above the x-axis, right? So when you graph it, you realize pretty quickly, oh, hey, that's never, right? So let's just go ahead and drag this here. All right, we'll go ahead and drag that there. All right, so the answer is that that's never above the x-axis. So what I can see from the calculator is that the answer is no solution. So then my question is, how could we have spotted that earlier? Because mathematically, we got that there's an answer, but there isn't an answer. There's no solution here, right? So that's my answer. These don't work, right? So the answer is not what I expected. It's not from 3 to 7/2. So let me go back to the sort of important step where I was able to spot that this is a trick. And remember, you're not always going to spot the trick. Sometimes you will, sometimes you won't. Now, I said I could spot it right here, but realistically, I'm going to guess that most of us are going to spot it at best right here. So let's go back and analyze why I'm saying that that's a trick. So at the moment, when I have that the square root of 2x minus 6 is less than -1, why am I able to spot that there's no solution? So right now, just looking at this, my brain says no solution. So no solution, right? That's what my brain says. Now let's talk about why. What do I know about the output of the root 2x minus 6? Well, I know that out of the root, right, physically coming out of this root that's all by itself, is either positive or 0. And I know that -1 is a negative number. 0 and positive numbers cannot be less than negative numbers. That's a big fat lie, which is why my brain jumped and said no solution, right? So just to be clear, the reason that I was able to jump and see that that was no solution, right, that there's no x value that makes this true, is because there's not going to be any x value that can make this statement true. Now, when you squared, the negative disappeared, and so you didn't catch that. So that's why you always have to check answers with roots. Even if I don't say check, and here I didn't, right, you still have to check answers that involve even roots because sometimes these crazy things happen. So let's go ahead and try a P6, right? So again, E6, no solution, and you can confirm that on a graphing calculator. All right, so same thing here. We're going to have two things happening, right? And again, it doesn't say check, but you should always logically check that your answer makes sense. So when we go to solve, right, we're going to solve 2 root 5 minus x, all minus a 10 is greater than or equal to -18. And at the same time, we also have to be worried about the domain, right? We have to be worried about two things. So I'm going to go ahead and start by solving, and then for the domain, I need the radicand, the thing inside the root, to be greater than or equal to 0. I guess I can solve this one first really fast because it's no big deal. So I get -x is greater than or equal to -5, meaning x is less than or equal to 5. So this is the first half that I need, right? But the other thing that's going on, right, is that I need to solve down here using SADMAP. So I'm going to do subtraction and addition first. I'll add the 10 over and get 2 root 5 minus x is greater than or equal to -8. Now again, at this moment, some of you might be able to spot a trick, and we'll go back to that in a second. So next, I'm going to divide by 2, and I'm going to get root 5 minus x is greater than or equal to -4. Again, at this point, some of you might be able to spot a trick. To get rid of the exponent, I'm going to square both sides. So I'm going to get 5 minus x is greater than or equal to 16. Right? And then I'll subtract the 5. So -x is greater than or equal to 11. And then x is less than or equal to -11. Right? So when you put all of this together, right, your brain's going to say that this is what the solution is. Your brain's going to say, okay, here's -11, here's positive 5 rather. I want this section and this section. So your brain is going to say it's this answer, but that's not right, okay? So the reason that that's not right, so this -infinity to -11 is not the answer. And I can check to see that it's not the answer, but here's a really easy way to check and see, right? When you check, you just check numbers outside of that interval. So let's say I pick an easy number. Let's say I pick 0, right? So when I go to check, let's pick an easy number outside of that interval. Let's see what happens if I pick x is 0. Well, I'd get 2 root 5 minus 10 is bigger than -18, right? That's definitely true, right? Because if it's hard to see that way, right, you could solve by adding the 10 over, and you would get that this, which is clearly a positive number, is greater than or equal to a negative number. That's definitely true. So x equals 0 works, which means that answer's wrong. Right? Now, it does make sense that I won't be able to plug in values higher than 5 because that's definitely a domain restriction. So it actually turns out that the final answer, right, my final answer is going to end up just being the domain restriction, and I'll walk you through why that's true. It's basically because all this work from here down is mathematically not valid, okay? The reason it's wrong, if we go back up here, and we will confirm this on a calculator, let's go back up to this step. Now, I told you I could spot it in this step before, but this is the easiest step to spot it in. I have a square root is greater than or equal to -4. Again, it's that same trick. The output of an even root is either positive or 0, right? And we're saying it's greater than or equal to a negative. Well, that is literally always true, right? That's going to be true for any x in the domain. So for any x in the domain of the function, like any x that I'm allowed to plug in. I still can't plug in I can't plug in, let's say, a negative or a positive 20, because that'll give me an imaginary number, but any x in the domain, and the domain was x is less than or equal to 5. So basically, since this is always true for any x in the domain, the only actual restriction is the domain, and none of this matters. Now you can see that if you put it in a calculator, and these are both trick questions. So to be clear on E6 and P6, I gave you 2 trick questions where in addition to solving the regular way, you have to logic it out a little and make sure that the answer makes sense. So if I were to put this into my calculator, the way I would put this in is in my y1, I would put 2 root 5 minus x. I'm going to add the 18 over, so I'm going to get plus 8, and I want greater than or equal to 0. So what this means is 0 or above. Right? That's what that means. So that's what I'm looking for with my eyes. So I'm going to go ahead and put 2 root 5 minus x, close the parentheses, plus an 8. And I want to graph it and look with my eyes for where this thing is above the axis. Well, sure enough, it's above the axis for any value smaller than 5, right? So basically, all of the values, it's always above the axis, right? And you could change your window to confirm that it's true, but this thing is always above the x-axis. The only wild card is that it has a domain restriction that you can't plug in x values bigger than 5, right? So you can see that that's, my bad. You can see that that's confirmed by the graph. You can't easily see that that's at 5. It is because I changed the window to go up to 20, but sure enough, this is exactly what we're describing here. It's this answer. So again, both of those are trick questions, but I want you to see some trick questions so that you know how to deal with them, right? All right, so let's do 2 more. Now on these, we're gonna solve by graphing. So that's telling you to solve in a calculator. There are 2 ways to do this. You can either do a y1 and a y2, right? And then find their intersection. I would suggest that the easier option is to subtract. Now, when I put a cube root in my calculator, I put it in as a caret 1/3. You can use a button for cube root in your calculator if you want. I'm not going to do that. And I want when this is less than 0, so that tells me I want when this thing is below the x-axis, right? So what I'm going to do is put y1 in as this crazy mess, and I'm looking for where this thing is below the x-axis. So let's go ahead and go to my y1, right? I'm going to do x minus 3, and then in parentheses, x plus 1 to the 1/3. And again, you could use the cube root button if you want in your calculator. I'm personally not a big fan. So I'm going to go ahead and zoom 6 and we'll see what happens. Right, so there's my graph, right? And if we take a quick screenshot first and then we'll find the actual values. So the windows that we're looking at for our answers are here, right? And since there's no equal to, that would be an open circle, right? And then open circle here, sorry, that inadvertently made a line. Open circle here to here, right? So those are the 2 intervals I'm looking for, right? So I need to second calc 0 and find those values. So we'll do second calc 0. I always start with the leftmost one. You don't have to, but that's just my preference. So I'm going to go over. Now watch, I want the signs to start down here because I'm to the left, so they're negative. I know that I've crossed the axis when my y has changed sign, so now I'm above the axis. All right, so that's my first one. So this one right here is going to be approximately 4.596, okay? The second one, so we'll do second calc 0 again, second calc, and then we pick 2. All right, so I want to make sure I stay to the left of this 0, so I'm still above the axis, and then I can tell I've crossed because the sign changes. So the second one, we'll just draw an arrow right there. The second one is approximately negative, oh, sorry, that was a negative 4.56. 1.04, either 1 or 2, right? You can round or truncate to 3 places, right? And then we'll do second calc 0, 1 last time. Work our way over. So I want to make sure I get the first boundary still to the left, and then I use that arrow to tell me to cross. I cross the axis, and the last one is approximately a 5.638. So this is approximately a 5.638. So once I know that, right, my answer is going to be from negative infinity to that first number, which is the negative 4.596. And again, from the negative 1.04, either 1 or 2. You don't have to write both. I write both as a teacher, so I know that you could be right if you wrote either of them. And notice they're all parentheses because there's no equal to here, right? So that's how we solve by graphing. Now you could also have done this as y1 and y2 and then physically look to see when this function is below this function, but I think that's much harder because then you have to pay attention to which function's which, and I think that's definitely more difficult. So I'm going to advocate for switching everything to one side. So again, I'm going to solve by graphing, right? Move everything to one side, so you're going to get x minus 1 minus a 3, and then this 2x plus 1 to the cube root. And you want when this thing is less than 0, so that's going to be below the x-axis, right? That's what you're looking for with your eyeballs. So your calculator can do the heavy lifting and actually find the values, but if you don't know what you're looking for, well, it's kind of useless, right? So you need to make sure you get the logic. So this is going to be an x. I'm going to go ahead and second insert minus 1 because that's going to be easier. Minus the 3, and then I'm going to second insert that this has a 2. And I think that's the right equation then, right? X minus 1 minus the 3, 2x minus 1 whole quantity to the 1/3. I'm going to graph it. All right, and then I'm just going to take a quick screenshot so that we can write all over this, right? And then we know, again, that we're looking for the intervals where this thing is below the x-axis, right? So you know that you want this interval and this interval. So you just need to find these 3 spots, right? So find this, and find this, and then once you know it, then you just have to write the answer, right? So we're going to do second calc 0. And I always start the farthest left. Again, you really don't have to do that. It's just my preference. That way I know which ones I've done. So I make sure I'm to the left of the 0. And then again, the y signs change. That's how I know I crossed the axis. So this first one is a negative 5.435, right, approximately. I'm going to do it again. So second calc 0. And now I want the next one. So I work my way over. I make sure I'm still to the left of it. Hit enter, and then I can tell I crossed the axis because the y has changed sign. The next one is x is approximately negative 0.571 or 2, right? And then the last one, second calc 0. We'll work our way all the way over. It's getting there eventually, right? When we get kind of close, go ahead and hit your left boundary and then cross the axis. You'll see the y has changed sign. And there's your answer. It's approximately a 9.007. So then my answer, right, my answer is going to be from negative infinity to negative 5.435. And again, from negative 0.571 or 2 to 9.007. And that is the end of our video and of chapter 8.